Okay, today we're talking about section 10.5, systems of linear inequalities and applications. These lovely symbols you should have seen back in previous sections of 090 something. We have greater than or equal to, less than or equal to. Notice that the equal to ones have these lovely little lines underneath it. That's the ones that mean equal to. In previous sections, you've also graphed these lines. So the greater than and the less than are the two lines that are dotted, and the greater than or equal to and less than or equal to are the two lines that are solid. The reason why they're solid is because of the equal to sign. So think of it, if you see the line, it's a solid line. Also, we are shading. So if the two greater than ones, you are shading above the lines. Depends on how it goes. If you're not sure, you can always pick an ordered pair and plug it into the equation and see if it's a true statement. If it is a true statement, then that means the shading happens on the side that you had. These two down here are shaded below the line. So we're going to start off with this lovely, lovely little equation. Inequalities. Y is less than or equal to 1/3 x plus 1, and y is greater than 1/3 x minus 3. When you're graphing a line, don't forget that you start with the y-intercept, which is the constant at the end, and you plot those points first, and then from there, you're going to plot your slope. Your slope is rise over run, but you don't do your slope until after you've plotted your y-intercept. So in this case, our y-intercept is positive 1. So we would plot that first, and from that line, we would rise 1 and run 3. Same idea down here. We would start with a y-intercept of negative 3, and from there, we would rise a positive 1 and run a negative 3. I'm going to show you that here in a moment. But this line right here, I want you to notice that this is less than or equal to, which means that this one right here will be a solid line, and it will be shaded below. And this one right here, which is a greater than, will be a dotted line because there's no little line under it, and it will be shaded above. So if we're looking here, once again, for the first equation, our y-intercept is a positive 1. We will rise 1 and run 3, solid line and shaded below. The second equation, our y-intercept is negative 3. Once we plot that, we will rise 1 and run 3. This will be a dotted line, and it's shaded above. So, what does that look like? It looks like this. Here is my y-intercept of the first equation. I have to plot that point, and from there I need to rise 1 and run over 3. Once again, from the y-intercept of positive 1, I rise 1 and run over 3. It was a solid line, and I shaded below it. Note I did the shading very light. I did it one direction so that I'll be able to tell the difference between the two. For the second equation, the y-intercept was negative 3, and from there I rose 1 and ran 3. Once again, it's a negative 3 y-intercept, so I rise 1 and I run 3. It's a dotted line, and it's shaded above. And this one I went this general direction because what I need to see is where they overlap. Where they overlap, the two things are going together. And in this case, they're overlapping in between the middle of them, and that's what I shaded pink. Do you have to shade it pink? No. You can, if you don't want to use a highlighter, you don't have to, but you should mark in there, this area is a little bit heavier shaded than the other parts, because in that way it makes it easier for me to tell where you overlapped. The next problem that we had on the page gave us 3. X with an inequality and y with an inequality means I have a vertical line and a horizontal line. The vertical line is going to pass through 0, which in vertical means I'm going up and down, and horizontal going through 0 means I'm going right and left. Both of them have the exact same inequality, so they are both solid lines, and they're both going to be shaded above. Both are shaded above. Now, for a vertical line, it's a little hard to have above when it's an up and down line. So for a vertical line, above means to the right and below means to the left, because what it really means is a greater than means I need numbers that are bigger than. Well, on a vertical line, things that are bigger always go to the right. And on a vertical line, things go smaller always go to the left. So above and below for a vertical line means you're either going right or left. Now, the other equation we have left, the x plus y is less than 3. That we need to rearrange so y is all by itself. So I subtracted x from both sides. So I have a negative x plus 3. It is a dotted line because there's no equal sign, and it is shaded below. The y-intercept in this case is 3, and the slope is a negative 1. When there's no number there, it's a 1, but it is negative. But it does mean, notice that it's a negative 1 over a positive 1. Once again, notice it's a negative 1 over a positive 1. So when I graph this particular line after I get 3, I'm going to rise down because it's negative. I'm going to rise down because it's negative, but I'm going to run to the right because it's positive. So, vertical line at 0, vertical line at 0. I need to shade above, which means I'm shading over, my apologies, I'm shading over to this side. So vertical line through 0, shading above means I'm going that way, which is the side squiggly that I did. The horizontal line of y is greater than 0 means here's my 0, and greater than means above. So I went this way for the shading. And then I have this lovely point right here. Here's my positive 3. And from here I rose a negative 1, which means I went down 1, and then I went to the right 1. This is a dotted line. Dotted line. And this one I think I shaded a different way. What you need to do is find where the 3 intersect. The vertical, the horizontal, and the diagonal one intersect, and it is in this lovely area right here. So that would be my answer. That would be my answer there. Turn the paper over. New problem. Once again, x in an inequality or y in an inequality, and that's it, means it's either a vertical or a horizontal line. This means it's a lovely vertical line through 1. It's going to be a dotted line, and it's going to be shaded above, which means it's going to go to the right. The other two equations, we have to move everything over. So we subtract x from both sides. So we have negative y is less than negative x plus 5. And I don't want a negative y, I want a positive y. So divide everything by negative 1. All three terms get divided by negative 1. Now here's the thing. Hopefully you recall from 09, I think it's 09, 03 that we did this in. When you divide by a negative and it's an inequality, you must reverse the inequality. When you divide by a negative number, the inequality is reversed. I like to call it a flipping negative. Man, oh man, it's such a pain in the butt because a flipping negative, it flipped the inequality. So that means that I now have y is greater than x minus 5. It's now y is greater than, not less than. So I reversed it. It's one of those lovely, lovely, lovely things that we had to change the direction it went. So it went from one way to another way. It went from this way down to this way because it's a flippin' negative. Flippin' negative. Don't you just hate that? So now my y-intercept is a negative 5. The number or the coefficient that's with x is 1. So if I write it as a fraction, it's 1 over 1. It is a lovely dotted line again, and I am shading above. It's dotted and shaded above. So that's what we're going to do over there eventually. The second equation that we're going to be doing is x plus y is less than 5. So move x over, so we have y is less than negative x plus 5. Y is positive, so I don't have to worry about reversing the inequality. It's positive. So that means my y-intercept is 5. And my slope is negative 1, which means that when I write it, it will be negative 1 over a positive 1. It will be a dotted line because there's no equal sign, and I will be shading below. Dotted and shaded below. So here's my lovely picture. I needed a vertical line through positive 1. That's vertical line through positive 1. It was a dotted line, and it was shaded above, which means it's shaded all over here. The next line that we had was the y is greater than x minus 5. So here is my negative 5. My slope was a positive 1 over 1, so I went up 1 and over 1. It was a dotted line. It's a dotted line, and I needed to shade above. So that means I'm shading all this area over here. I do believe I did the sideways one for that one. And then the second line was y is less than negative x plus 5. So there's my y-intercept of positive 5. My slope was negative, so that means it was negative 1 over positive 1. So I go down 1 and to the right 1. It was also a dotted line, lovely dotted line, and it was shaded below. So there would put below. So when the 3 intersect, it would give me a lovely little triangle like this. Lovely little triangle. The last thing it wanted us to do, let me zoom out here for a second, was to find the equilibrium price and quantity for the following supply and demand equations. Now, supply is how much you have, isn't that wild? And demand is how many people want it, whatever it is, be it a car or a food product or whatever. Supply is how much you have, demand is how much the people want it. The equilibrium price is the price where the supply is equal to the demand. Where the supply is equal to the demand. My apologies. Now, D and S. D would mean that's your demand equation, and S stands for your supply equation. If we want them equal, if we want the equilibrium price, that means we want them to be equal.